Hi, everyone. Before we start the panel discussion, I would like to thank all the speakers for their excellent presentations. In the panel, I have with me, sitting next to me, Professor Alexis Lau, and also joining us, online, we have Grace Kwok. Grace, how are you? Can you say hi?
Hi, everyone.
Hi, thank
Thanks
you.
for having me.
Yeah, our pleasure. And also we have Chris joining us from the US. Chris, how are you doing? We cannot hear you. Can you unmute your mic, please?
Yes, good.
Okay, good. Okay, confirm it's you, Chris.
Yes.
Now, Chris, since we have you on the mic, maybe the first question for you. Now, listening to your presentation, you talk about, ambient air pollution concentration trend in Hong Kong in the past few years, and you also emphasize, the associated health risk. With NO2, for example, going downward, but ozone going upward. And then you mentioned there's some offset in terms of the health risk. Now, with, as far as I understand, with ozone, having an upward trajectory, are you worried, or, what should we, pay attention to in the future in terms of, total health risk in Hong Kong associated with air pollution?
Yeah, well, I think the good news is that the indicators of total health risk and that I showed, and also Jimmy Fung showed a sort of similar result in his talk in the prior session. When you look at multiple pollutants, although there is an increase in ozone concentrations that's well discussed at this meeting, it's offset by the decrease in NO2, in SO2, in PM2.5 and PM10. And so in terms of the overall mixture of air pollutants and health impact, things are generally going in the right direction. However, more can and should be done with ozone. But there was a question in the prior session to Dr. Fung that I just want to emphasize. I agree with his answer. But it is important to continue to reduce NO2 for its own sake. And also NO2 is a precursor to some of the secondary PM. And of course, fine particles. In my talk, we didn't quantify the health risk of fine particles. The biggest contribution of fine particles to health risk is really long-term mortality. And in most benefit cost assessments that I've seen in Europe and the United States, the benefit of reducing PM2.5 concentration and its effect on reducing premature death really outweighs almost all the other health effects by an order of magnitude. We focus in our talk today on the short-term health risk, and of course that's also important. So the bottom line is I think things are moving in the right direction, except for ozone. The good news is the net mix of health effects is improving, but definitely it is worth targeting further reductions on ozone and to continue to target reductions on these other health-related air pollutants.
Okay, thank you, Chris. I think that's very clear, and thank you for your explanation. Now, I'd like to move on to Alexis. Alexis, in your presentation about Praise Hong Kong, you are now into the second phase of your project. Now, I recall Professor Zhu Tong's presentation. He talked about individuals actually will have different impact or getting different impact based on exposure. So basically, they have different vulnerability, and that's why I think we need to study more in terms of who they are, their medical background, history, and maybe some other socioeconomic factors that's in play as well. So my question to you, Alexis, is, if we have to go into that kind of level of details to understand who are being exposed to a certain level of air pollution, is it what you're planning to do in the next phase of Praise Hong Kong? Because then that's exactly what you are envisioning, and that is trying to personalize this information for the benefit of individuals.
Yes, thanks very much for the question. Actually, one of our goals when we think about the Praise Hong Kong project is exactly because we've been working on air quality for many years. And when we talk with health experts like Professor T.W. Wong in Chinese U, as well as a lot of other experts, it's very clear that different people are susceptible differently. But how to get this information? Because most of the epidemiological study are from population data, both in terms of exposure as well as in terms of health impact. So we notice with now we are talking so much about smart city, there's really a lot of new technology development that we are talking about. We have potential to track. Certainly, we need the permission from any user that participate. But if we have information about personal exposure as well as personal health endpoint effects, we should be able to answer the question much better. So our project is really one of these first attempt that we want to merge the smart city, smart technology app with our own domain of interest, which is air pollution. So in the second phase, we are very interested in quantifying exposure of different people. And then in our third phase, we really want to, with the user's permission, get some health data from them or their health effect, and then try to quantify and also understand the variability within population of this type of health effect.
Okay, thank you, Alexis. Now, talking about exposure, actually in this session, we have a few presentations about exposure. For example, Professor Ho, in his presentation, he's talked about personal exposure, and also he mentioned quite a bit about microenvironments and how much time we spend, for example, indoor, in office or at home, and what will be the associated health risks based on that exposure level. And also, with Dr. Shak's presentation, he talked about indoor air quality because, based on Professor Ho's presentation, typically, we spend a lot of time indoor. And that's why we really need to look into indoor, environment and situation. Now, Dr. Shak talked about real-time monitoring. And I don't know whether that's feasible right now or, how much that would cost. I think that certainly will be questions asked by, office, owners and, other, operators. But maybe that's something we can, ask Dr. Shak later on. But since we have Grace with us here, so I would like to ask a question related to Grace's presentation. Grace, you talk about also relating to indoor air quality, how we can improve indoor air quality standards, especially with buildings, how to enhance, green building performances and think about people's wellness. Now, you talk about indoor ventilation standards. Can I ask you a question? Is it mainly for new buildings? Because as far as we know, most of these standards mainly cater for new buildings. So as they design and build new buildings, they have to fulfill certain standards. But what about existing buildings? So in your mind, in your plan, do you think some of the ideas can also be applied to existing buildings? That's something we have to deal with, certainly. Grace?
Yes, definitely. In fact, the green building standard is now under revision with the new information that we've got from the pandemic studies, the studies related to pandemic, and also because with the increased awareness of the public on air quality management and its relationship with the health effects. So I think the changes would be on both the standard for new and existing building. And besides updating the standards related to design and operation of the air ventilation system and air quality management, also there will be updating about the monitoring requirement. Just like Dr. Shak has mentioned that monitoring the indoor air quality once a year is not enough. And in fact, this is something that we are also considering to incorporate it into the green and healthy building standards.
Okay, thank you, Grace. Looking at the screen, actually, we have quite a few questions, mostly for Alexis. Now, Alexis, it's quite a long question, but I try to summarize. I think first question from Kevin is asking about how you use the measurement data that you get from multiple sources and how you can then use it in your model.
Yeah, in terms of data fusion, actually there's a few layers of data fusion, because first of all, to get the air quality model right, because one of the specific questions, how do we try to merge ADMS and CMAQ? CMAQ is a more large-scale model, so its requirement in terms of the details is not as much as ADMS. ADMS require us to know detailed street-level information. So for those, we use our maxim model, which simulate the row condition, and then that generates a input data, which we can then process and fill into CMAQ. But after the CMAQ output, we then really use that to reinforce the ADMS so that those will give us a consistent high resolution result. But those are historical information because we use historical information to generate the average emission. Then we need to have real-time information, like in any smart city, they are now reporting road condition. By understanding the variation of road condition, we use a big data type of, I would say, neural network type of information to merge things into, to get a short term, because we don't have time to run the model over and over again if we have some short-term change. So I think there are multiple layers of the data fusion, but we also think that this would be the future, because with smart city, we will have more and more information, and but no matter how much information, it would not be all comprehensive. So a model will be necessary. So a combination between real-time as well as historic data combined with a good model, I think would give us all the different benefits that we need.
Okay. Thank you, Alexis. Moving on to the next question, again about data. Now this time, how you obtain real-time quality outdoor, indoor air quality information. And also, with the app, how you implement data fusion to integrate all the information.
Okay, I think I answered the part on data fusion earlier. In terms of outdoor, indoor, we actually spend a lot of time using personal monitor, like something like this, which I have with me, to measure the air quality for a person as they move around. So like this sensor, I have it with me for the last 1.5 weeks. And I also can compare what is estimated by the model outside. So we try to set up, understand the relationship of how the indoor air quality and outdoor air quality is related under different conditions, like whether the window is open, whether that particular shopping mall has, different type of ventilation setting. So we try to use this to model what people are having when they are inside, with a few data points that we establish. So we have over 200 over multiple week measurement right now. So we are trying to infer that. But one of the things is we think the more important message is that actually a lot of our study has already shown that by doing something indoor, like something as simple as closing the window when the air quality outside is bad, that can already reduce the air quality a lot. So I think this is the message we want to get people to understand, so that they can say, okay, when the air quality is not good, there are quite a big thing of things that we can do to help ourselves.
Okay, thank you, Alexis. Alexis, since you are showing or actually showcasing your sensor, now I want to also engage Chris and Grace on this topic. Chris, if I remember correctly, you're also very familiar with these sensors. And I remember, maybe a few years ago, when we talk about, using these sensors, one question always popped up was, what about data quality? Can we trust the data? also, how are these machines or sensors being operated? Whether the authority will accept those information. So to you, I'd like you to say a few words based on your experience in the U.S. Chris?
Okay. Yeah, I'll try to be very brief. So, because it's a big topic, but so the bottom line is that these small, what we often call low-cost portable sensors, come in different flavors. There are kind of research-grade sensors that are commercially available, and then there's the lower-cost sensors that are based on $20 US components. And so they do vary in data quality, but in our project, we've taken great steps to validate these instruments compared to either federal reference method or federal equivalence method monitors that you would find at regulatory air quality monitoring stations. So we've done side-by-side comparisons over many hours. One of the things we're really interested in is the relationship between indoor and outdoor concentration. And so for that purpose, we need to have a pair of monitors that give the same answer under the same condition. And so, one thing that Alexis and our team has really emphasized is before we divide two monitors and have one outdoor and one indoor, we put them together and we measure them together for hours or weeks. And then we do that before and after we split them to the indoor and outdoor location. And so that way we can identify instrument drift. And then Ning Ji, who I know is going to talk in the next session, has really done a lot to understand the sensitivity of these instruments to temperature and humidity and interference with other pollutants, and to develop corrections for that. So I don't think we're going to claim that these are a regulatory air quality monitor, but they are useful for our intended purpose, which is to quantify temporal variation in exposure and inter-individual variation in microenvironments and in personal exposure.
Okay, well, thank you, Chris. I think that's very helpful. And to Grace, related to what Chris just mentioned, do you think these machines, these sensors are, what we're looking for to enhance indoor air quality monitoring, especially continuous monitoring, based on, Dr. Shak's presentation, and also you mentioned the standards, being part of the standards, we need measurements and data. So do you think we can use these sensors in a much more extensive way to fulfill that, that need?
Yes, I think the technology for the sensors has developed in a very advanced way, in recent years. In fact, using the sensors, in fact, we can map also the indoor air quality indoors. So this is, I think, is a way that how we can use the innovation and technology to help us to assess the exposure and also identify any hotspots or area that we need treatment or special care when we are trying to improve the indoor air quality in the buildings.
Okay, thank you, Grace. Now, I think we still have 2 minutes. Now, I want to ask each one of you a question that's related to, Alexis, your last slide. You mentioned total exposure management. It's like a progression, starting with source control, then air quality management, and you mentioned for the future, actually, we should take this approach to think about exposure and how we manage our exposure level in different micro environments. So to each of you, maybe just say a few words what you think about where we are, what needs to be done to move us forward in this direction. So maybe I will start with Chris.
Yeah, I'd like to put in a plug for a poster that partly addresses your question. It's poster 409. And this is part of the PRAISE project, but we've done a standalone stochastic population-based model of inter-individual variation and exposure. And it illustrates the same general points that Alexis touched on, which is that there's tremendous variation in how much air pollution penetrates to different enclosed microenvironments that is potentially controllable. And so I think this is a key story, and this affects both personal decision-making as well as institutional decision-making, And I think Dr. Scheck's talk was a good example of how, building management can incorporate best practices aimed at indoor air quality, just like individuals can make their own choices. So I think there's a lot to say for both, individuals, institutions, government, all have a role in helping to promote exposure management. And the one takeaway from our poster is there's a lot of variability in the ratio of exposure to outdoor concentration. And that means there's a lot of opportunity to manage your exposure, which is really how you manage your health risk.
Okay, thank you, Chris. Grace, indoor air quality actually is an important component of total, exposure management. So what's your thoughts on that one?
In fact, I think I think about it like if from the green building and the healthy building perspective, in fact, we are considering something called indoor environmental quality management. So it includes not only the air quality part, but also other aspects like the acoustics and also the lighting quality. And in fact, with the technology, we have now the different kind of sensors and also the correlation of these different aspects during the operation of the buildings. I think it would be a good place to study, to think about the environmental quality management as a whole. Yes.
Okay, thank you, Grace. Hopefully, these conversation will lead to further collaboration after the conference. Now, Alexis, over to you. I'll give you the last word.
Okay, I think I would echo very much on what Chris has said. I see that certainly government has a responsibility try to improve the outdoor air quality as much as possible, and they probably also can help even in the indoor air quality in terms of providing certain guideline as well as showcase good example of what can be done indoor. But I think it's very important for us to understand personally there's a lot of things we can do ourselves to, in particular, when air quality is bad during maybe a pollution episode because of meteorological condition. So this will help us in the longer term to really have better health.
Okay, thank you very much, Alexis. In the interest of time, I think, even though we still have a few questions, I think what we will do is we will pass the questions to, the speakers, and, they will answer the questions through the organizers. And so please join me to thank our speakers again, and the panelists, Alexis, Chris, and Grace. With that, I declare the close of this session. I will see you back at 2 p.m. sharp after lunch. Thank you very much. Bye-bye.